Hello and welcome to class. Today we are going to prepare for the gateway solving exponential equations. Now to get to this from home or from away from school, go into Canvas and choose our class and go into Files. There's a folder called Teachable Moment Worksheets Semester 2. In there are worksheets. The one we are on right now is number 14, solving exponential equations. Now, I would encourage you to you could print this or you can open it up in some writing app on your iPad. I'm going to choose to open it in Notability. So now it's sent it to Notability. So the next thing I'll do is I'll open up Notability and it'll say that it's been sent there. I'm going to create a new note and I'm going to choose the folder I want it in. I want it in my Algebra with Stats folder, and I'll say done. Okay. Now I'm going to open it up, the worksheet. So this is what we're going to try and explore today. You can see there are 6 problems that we're going to do. There are links to 2 different websites if you want to see other ways that these are solved. And I'll actually show you some of those. So we don't use this very often, but if you click on the links on the worksheets, it'll take you to a website. Most of them are from a site called Purple Math, and because I think this website is well done. So what it talks about is solving exponential equations from the definition. There are 2 ways to solve exponential equations. One is from the definition, and that is this way. And that is understanding that if you have something like this that says 5 to the x equals 5 to the third, since both the bases are 5, that implies that x has to equal 3 for them to be the same. Now that one was an easy one. This one's a little bit harder. 10 to the 1 minus x equals 10 to the 4th. And again, since both of the bases are the same, the exponents, 1 minus x, has to equal 4, as you can see in this equation. Then you solve for x by adding x to both sides and subtracting 4, and you get negative 3. Now you might get one like this, where the bases don't appear the same at first. 3 to the x equals 9. Now, if we can write both of them with the same base, meaning that if we can write 9 with a base of 3, then we can solve it using the definition of exponents. Now what we want to recognize is that 9 can be written as 3 squared, as is shown here. So that means 3 to the x equals 3 to the second, which of course implies x equals 2. Similarly here, 27, we have 3 to the 2x minus 1 equals 27. 27 can be written as a power of 3. So both of them can be written with the same base. So 27 is equal to 3 to the third, as you're seeing here, which then means 2x minus 1 equals 3, and then 2x equals 4, and x equals 2. So that is how you solve equations, exponential equations, using the definition. Okay. So let's try that on our own worksheet. The trickiest part is going to be how to figure out how to write these with the same base. Now, as a hint, all the ones on the left we're going to solve by the definition as it says here. All the ones on the right we're going to solve by using what's called logarithms, and I'll teach that in a second. So, the definitions mean that we can write both 4 and 1/2 as the power of something that's the same. All right, so let's think about what that's going to be. So 4 can be written as 2 squared. So this can be written as 2 squared to the x power. 1/2 then must also be able to be written as a power of 2 to the x minus 3 power. Our question is going to be to figure out what power goes here. Okay? what power of 2 gives us 1/2? Well, hopefully we recall that that is 2 to the negative 1. Because again, when you raise a number to a negative exponent, it means you're dividing by that number repeatedly. So what this means is that we're taking 1 and dividing it by 2, which would give you 1/2. Okay, that's the first step. Okay, and that's actually likely to be the hardest step for us. Now, the next step, I'm going to change my format here. The next step is to use what we used 2 gateways ago, and recognize that when we have a power raised to a power like we do here, I'm going to make this a little smaller. So a power raised to a power, then you multiply them. So this gives you 2 to the 2x, which equals 2 to the negative 1 times x minus 3. So when you raise a power to a power, you multiply them. And we spent some time learning that. And I can go through that with you again if you need to in class. Now we're in pretty good shape, because now we have 2x over here and negative 1 times x minus 3 here. They both had the exact same base. What that tells us then is that 2x must equal negative 1 times x minus 3. And I don't like minus 3, so I'm going to change it to plus a negative 3. Now, if you distribute the negative 1, you get negative x plus positive 3, because the negative signs cancel out. Now, if we add x to both sides, we get 3x equals 3, which gives you x equals 1. That's our solution. Okay. Now, it's probably not enough to have you understand it yet, but let's try another problem. So 3 is already as simple as it can be. So we have 3, I'm going to put parentheses, to the 5 minus 3x. So that means 81 must be able to be written as a power of 3. Okay, we got to think, okay, how do you write 81 as a power of 3? 3 squared is 9. 3 to the third is 27. 3 to the fourth is 81. So this equals 3 to the fourth. All right, same thing as last time. We have a power raised to a power, so we're going to multiply them. So we get 3 to the 4 times 3 minus x equals 3 to the 5 minus 3x. What does that tell us? It tells us that these two things have to equal each other because the bases are the same. So 4 times 3 plus a negative x, I'm changing it to plus a negative again, equals 5 plus a negative 3x. We distribute the 4 in here. You get 12 plus negative 4x equals 5 plus negative 3x. I'll then add 4x to both sides. You get 12 equals 5 plus x. Subtract 5 from both sides. You get 7 equals x. Okay. That's the second one. All right. We have one more to do together that's like this before we learn the second style. All right. So we look at this one again and we see we have a 9 here and a 1/3. We think, okay, can we write this as a power of a smaller number? The hope is that you would recognize that 9 is 3 squared. So you can rewrite 9 as 3 squared. So instead of 9 to the x minus 3, it's 3 squared to the x minus 3. What that means then is that this must be able to be written as a power of 3. All right, and if you remember question number 1, if you raise it to positive powers, it multiplies. If you raise the number to a negative power, it divides. So if you raise this to the power of negative 1, you would get 1/3, 1 divided by 3. Okay. And powers raised to powers again, multiply. So we get 3 to the 2 times x minus 3 equals 3 to the negative 1 times x. All right, since the bases are now the same, the powers must be equal. This will give you 2 times x plus negative 3 equals negative 1 times x. Distributing these in, you get 2x plus negative 6 equals negative x. Adding x to both sides, now you get 3x plus negative 6 equals 0. Adding 6 to both sides, you get 3x equals 6. And dividing by 3, you get x equals 2. All right, so that is how you solve exponential equations by using the definition. And what it says here is equating the exponents, making sure the exponents are the same. Now, if we go back here, and it's going to reload here, which is fine. So I'll show you how to get to it again. Algebra with Stats, Files, Teachable Moment Worksheets. This is worksheet number 14. And we can click on this second link. It'll take you to a different web page. Now this is solving exponential equations with logarithms. So sometimes you can't always equate the bases and use the definition. You're not going to be able to find them to be the same. So we're introducing something new today. It's called a logarithm. And it seems very complicated, but it's not any more complicated than addition or multiplication or square rooting. All those just mean something to us now. And those feel more comfortable to us because we've used them so often in our life. Logarithms is the same idea. It's just an operation that you do on numbers to make something happen. So addition puts things together. Multiplication sets them in groups of the same. Okay, and we learned that exponents is just repeated multiplication. Logarithms are just the opposite of exponents. Okay. For instance, if we have 2 to the x equals 30, we might think, well, what power of x gives us 30? Well, 2 squared, no, that's 4. 2 to the third is 8. 2 to the fourth is 16. 2 to the fifth is 32. So it's somewhere between 4 and 5, but it's not exactly 4 or exactly 5 because it's not quite right. So to solve this, what we can do is we can use a logarithm. And a logarithm is just the opposite or the inverse operation of raising something to an exponent. Okay. So what it shows here is that if you take log base 2 of both sides, log base 2 of 2 to the x, and log base 2 of 30, you will cancel out. The 2 to the 2, the power of 2 will cancel out. So log base 2 of 2 is 1, which will give you x. And then log base 2 of 30 is your answer. Now, that's probably seems a little complicated, and it is at first. But with some practice, we'll make sense of it. So what I'm going to do here is I'm going to go down and write some notes for us. So if we had, there we go, 3 to the x equals 27, this can be rewritten as, we'd say, take log base 3 of both sides, so to get rid of the 3, which is this base here, you take log base 3. Just like if I had over here, I said x squared equals 16. You'd say, well, how do you get rid of the squared? Well, you could either square root, okay, or we learned you can raise it to the 1/2 power. Okay, So that will undo what's being done. And that's how you want to think about this. This here, this log base 3 undoes this base. Okay. So what you end up getting is just x, because log base 3 of 3 will cancel out. So x is equal to log base 3 of 27. Okay. And log base 3 of 27 you can do in your calculator. But log base 3 of 27 is indeed 3, because 3 to the third is equal to 27. So you actually find this one easier than the last one, although it probably feels more complicated right now, because there's a very simple technique to solve them. And once we do a few together, it'll be fine. So here, what do we need to get rid of? Well, we need to get rid of this e. Oh boy. Okay, so this is another difficulty when we start dealing with logarithms. We introduce, oftentimes, math books introduce this idea of e. What is e? Well, so answering that question is like answering what is pi. So pi is approximately 3.14159, and it goes on and on for forever. Okay. E is the same. Okay. E is 2.178 something something something, and it goes on forever. It's just a constant. And there are, just like pi, which is related to circles, E is related to powers, and there's lots of reasons why E became an important constant for mathematics. So E is just like it's just a number. So how do you get rid of this base? Well, we do log base E of E to the negative x equals log base E of 9. Okay. Now, log base E of E cancel out. So to get rid of a base, you just take log base, whatever base you're trying to get rid of. So this gives you negative x equals log base E of 9. Okay. Which means x equals negative log base E of 9. Now, you can absolutely leave it like that, or you can stick it into your calculator and find out. Okay. Okay. Now, this can be done in many calculators, but I'll have to probably show you in class how to do it in your particular calculator, and you could get an approximation of what this value is. Okay. Okay. We'll go on to the next one. Okay. The next one will be a little more complicated, because before we can get rid of the base, which is this part, okay, that's the exponential part, we need to isolate it. So we're going to subtract 3 from both sides, and you get 2e to the x minus 3 equals 12. Okay, that's close, but it's not quite isolated yet. Okay, there's still this 2 out front. So now we have to divide by 2. So we divide both sides by 2. Now you get e to the x minus 3 equals 6. Now it's isolated. Okay, now the base is by itself with just its power. It just has the base and its power. Now the power can have whatever you want in it, but there shouldn't be anything outside of the base. Now to get rid of the base, that's the new skill. You do log base E of e to the x minus 3 equals log base E of 6. So if you do log base E on both sides, just like square rooting both sides, just like dividing both sides, okay, in this case, it'll cancel out over here, and you get x minus 3 equals log base E of 6. And if we add 3 to both sides, you get x equals 3 plus log base E of 6. Or you can write log base e of 6 plus 3. Okay, and that's our answer. Or you can put in your calculator and get an approximate value. Okay. This one actually might feel easier to us now. What you're seeing is the base is already isolated. There's nothing outside of the 7. There's not a plus or a multiplication outside there. It's just the 7 and its exponent. So we can go right to getting rid of it. So log base 7 of 7 to the 2x. Okay. And log base 7 of 20. Okay, so we did the same thing on both sides. Log base 7 on both sides. Now the log base 7 of 7 cancels out. You get 2x equals log base 7 of 20. Now you probably are aware, although it seems more complicated here, but to get rid of the 2, we just simply divide by 2. And you get x equals log base 7 of 20 divided by 2. And that's your answer. You can also plug this into your calculator and find an approximate value. All right, so that is our lesson for this gateway. Oops, I forgot to square that in. So I encourage you to hopefully watch through this video with your day today for your lesson. If you need to, watch through it again. And then feel free to email or ask me any questions you want next time we see each other.